7.4 hypergeometric distribution. So let's just look at this question. So the probability of success changes as each trial is made. The random variable is the number of successful trials in experiment, and most of the questions needs using combination. Let's look at this. Determine the probability distribution for a number of women on a civil court jury selected from a pool of 8 men and 10 women. You know, with the jury, you need 6 juries, right? You want to find the probability distribution. You might choose no woman, right? In C, you choose 0 out of 10. And juries in a civil court jury, we have 6 people. These 6 people would be selected from all men, so 6 divided by total events gonna be when you're choosing 6 out of 10 plus 8, 18. So that's give you the probability that the 0 women selected and all of them is from the men. So then you select 1 woman out of the 10, so the rest of that will be chosen from the men, and again series 6, 18. You can continue now 2 women and so on. This will give you the probability distribution. You see in this table here for 0 women, here is for 1 woman, 2, 3, and 4, and here is when all of them is from 6 women, 6 juries is from women. Now the number of your variable is going to be 0, 1, 2, 3, 0 woman, 1 woman, 2 woman, 3, and so on. The random variable is here. Then you can draw the probability distribution. These are your random variable, and here is the height of this. Each of this line give you the probability. Okay, so the expectation value said, what is the expected number of the woman on the jury? You know the expectation value is x multiplied by p of x, random variable multiplied by the probability of that, and add them up. So basically 0 multiplied by 0.001 plus 1 multiplied by 0.03 plus 2 multiplied by that plus 3 multiplied by that, and so on. You continue and add them up. As you see that there, 33.32. Now here's the equation of when you have hypergeometric distribution, C of x a, C of r minus x and minus a divided by r n. A is the number of successful outcomes of the total n possible outcome. In that example we had 10 women, and n was the number of the total of them, which is 18. Now, if you want to formulate the expectation for hypergeometric distribution, R divided by A divided by N is successful divided by total, and R is the event, repeating events. Just look at the question. Calculate the number of women on the jury, example 1. Okay, I know the number of the women was 10, N was total was 18, and R, we want to choose 6 women. So the other event is going to be 6. 6 multiplied by 10 divided by 18, so you get the same thing as before, 3.33. Look at this question. A box contains 7 yellows, 3 greens, 5 purple, 6 red candy jumbled together. What is the expected number of the red candies among 5 candies pulled from the box? So they're red. How many red we have? we have 6 red. What is the total if you add 3, 7, 3, 5, 6? You will get 21. Now, since I want to find 5, so my event is going to be 5. So it's going to be 5 multiplied by that. Remember that it was R, A divided by N. This is A, your success is red, N is total, and 5 is your event. This is what we have, 5 multiplied by 6 divided by 21, 1.4. If you want to use the other method to do the expectation of hypergeometry, you can try that. So if you choose 0 from 0 red candy, we had total 6 red, 0 out of 6, and the 5 will be chosen from the rest of the candies, which is 15. So about the total outcome, which is 5 selected from 21. If you choose 1 red candy, 1 out of 6, so the rest of them, which is 4 out of 15, and divide by total, you make sure you multiply it by the random variable. So this is 0. Red is 1 red, 2 red, 3 red, 4 red, and so on. You add them up, you will get the same number. In the spring, the Ministry of the Environment tagged 500 raccoons in a wild wilderness area. The raccoons were released after being vaccinated against rabies. To estimate the raccoon population in the area, the ministry caught 40 raccoons during the summer. Of these, 15 had tags. Determine whether the distribution can be modeled with a hypergeometric distribution. The 40 raccoons captured during the summer were all different from each other. So they are not objects, so they have a different member. In other words, there were no repetition. So the trial were dependent. The raccoons were either tagged or not tagged, success or failure. The situation does have all criteria for hypergeometric distribution. Now, let's see the raccoon population in the wilderness. So we know that 15 out of 40 were tagged. Now 500 is tagged. I want to know the population here. So n is equal to 40 multiplied by 500 divided by 15. That would be the population of the raccoons. We can use these expectations values to do that. So you do the even numbers here and send your work to teacher.